Morning, students. Good afternoon, students. Last class we started the fourth unit of electrical distribution system, that is the power factor control or power factor improvement, right? Power factor improvement. Fourth unit, so three parts is there. First part is power factor improvement. Second part is voltage control. Third part is manual methods of voltage control or voltage distribution calculation. That is nothing but that. Third part is already discussed in the second unit. So calculation of AC voltage, AC distribution voltages voltage drop calculations. Power factor referred to the sending end voltage, power factor referred to the respective load voltage, right? So part 3 already studied in the second unit. Even though we have studied in the second unit, I am explaining once again here also. So the big unit compared to EDS subject, so fourth unit is the very big unit, that is it may take more than 20 classes also. So first we discuss about the power factor. Generally last class I am explaining the what is power factor and what are the causes of low power factor, what are the disadvantages because of that low power factor, what are the problems arises in the distribution system, that is causes of low power factor, disadvantage of low power factor. Then how can you improve the power factor? How can you improve the power factor? That means what are the methods to improve the power factor? Right? Up to power factor improvement methods. We'll explain last class. What is power factor? What are the causes of low power? Disadvantage improving methods. Right? Once again, just 5 to 10 minutes. Some of the people are not attending, not joining the class. Just only 4 members will be joining the class. That's why I am repeating once again. So up to 5 to 10 minutes. Then I am going to the today's class. So what is power factor? Generally, power factor is nothing but a cosine angle between the voltage and control. That is nothing but, as you studied in the last semesters, that is 2-1 electrical circuit 1. So definition of power factor is nothing but cosine angle between the voltage and current. So cos pi is the power factor. Maximum value is 1, minimum value is 0. That means 0, 0 to 1. And it may be equal to 1 is nothing but power factor is equal to 1, or power factor is nearly unity is nothing but that system or that industry maintains a good voltage profile. That means to maintain the good power factor, that may gives the benefits to the industrials or consumers also. Why? Because as power factor reaches to nearly unity, the consumption of electrical power may reduced. Consumption of electrical power may reduced is nothing but the price per unit area selling by the given to the distribution company is reduces. Cost per price is reduces, right? That is the effectiveness. So and also the equipment may work efficiently also, right? So that is simply say that power factor is nothing but cosine angle between the voltage and current. But in distribution, that definition is suitable for network theorems only. So here also suitable, but coming to the distribution system is nothing but active power, reactive power, voltage, right? So we have to increase the power factor, means we have to observe the power factor in terms of powers. We have to draw the power triangle. So real power, reactive power, apparent power. A triangle. Real power, reactive power, apparent power. Right? So from that definition, from that power triangle, power factor is the ratio of active power to apparent power. Active power to apparent. You have to draw the diagram. So I give a, so look at the figure. So this is figure 6. Look at the figure 6.2. So OA is the VI cos pi. VI cos pi is nothing but active power. AB is the VI sin pi. VI sin pi is nothing but reactive power, right? And VI is the apparent power. Now taking this is the angle pi. Now cos pi is nothing but adjacent side by hypotenuse. So cos pi adjacent side is nothing but VI cos pi by VI. VI cancel, V cos pi will be available. But VI, what is the VI cos pi? Real power or active power. What is the VI? Apparent power. Therefore, what is the definition of power factor? So it is the ratio of active power, that is kilowatt, to apparent power, that is kVA, of an electrical installation, whatever it may be. So it is the ratio of active power to apparent power, that is cos pi is equal to kilowatt by cos pi. Therefore kilowatt is equal to cos kVA into cos pi, right? Now this is the power factor definition. Another definition also there. That definition already all persons are well known, and that they studied in the electrical circuits, right? So we are taking this is the figure 6.2 is the power triangle, that is drawn between the active power, reactive power, apparent power, right? But coming to this one, so the resistance or impedance triangle. Suppose we have taken the impedance triangle. This is the R. So this is XL. So this is Z. So cos pi is nothing but R by Z. Impedance, resistance by impedance, right? So this definition we have studied in the resonance condition. So at resonance condition, what is the power factor? Unity. How can you come the unity? At resonant condition, impedance is equal to resistance. Impedance Z is equal to resistance. That means at resonance condition, circuit behaves as a resistive only or unity power factor. That is nothing but R is equal to Z is equal to R. Now substitute power factor is equal to R by Z, but Z is equal to R. Therefore R by R, that is equal to 1. So at resonance condition, the power factor of particular system or series circuit is a series resonant circuit is a unity. So from the resonant circuit, this definition is comes to a picture. From the power circuit, so this formula is come to the picture. From the normal cosine angle between the voltage and current, that is the another, right? So totally power factor is nothing but ratio of reactive active power to apparent power, otherwise ratio of R by Z, otherwise cosine angle between the voltage and current. Maximum value 0, sorry, minimum value 0, maximum value 1. So generally, so below 0.8 or below 0.7, the power factor may be maintained below 0.8, then the system may having low power factor. అయితే పవర్ ఫ్యాక్టర్ ఏ ఇండస్ట్రీ అయితే పవర్ ఫ్యాక్టర్ని బిలో 0.8 మెయింటైన్ చేస్తున్నారో ఆ సిస్టమ్ అనేది లేదా ఆ ఇండస్ట్రీ అనేది టోటల్ ఇండస్ట్రీ యొక్క పవర్ ఫ్యాక్టర్ అనేది లో పవర్ ఫ్యాక్టర్, రైట్? సో మోర్ దెన్ 0.8 దేర్ ఇస్ నో ప్రాబ్లం. సో 0.9, 0.99, 0.99, రైట్? So now how can you reduce the how can you improve the power factor is nothing but so by connecting a capacitor across the line, right? So before going to that one, what are the main causes of low power? అసలు low power factor అనేది ఎందుకు వస్తుంది? Definition of power factor is nothing but ratio of kilowatt by kVA, otherwise active power to apparent power or real power to apparent power, what it may be. So what are the causes of low power factor? Generally, in industries or outside of the world, the motors may be utilized to pump the water. Otherwise, some of the industrial motors or some of the equipment motors also we three-phase induction motors, right? Three-phase induction motor in the sense it is inductive coil. That may be equal to transformer also, right? Three-phase induction motor may be equal to transformer also. How can you say that three-phase induction motor may be equal to transformer? Stator is equal to primary winding of a transformer. Rotor is equal to secondary winding of a transformer. So such that the three-phase induction motor may be equal to transformer. That means both are inductive circuit. So and also induction generator also, right? And discharge lamps, high intensity discharge lamps, whatever it may be, arc lamps, all these may be under inductive nature. Inductive nature is nothing but it is having lagging power factor. Now, how can you improve that power factor? A capacitor is connected across the equipment. That capacitor having leading VARs that may neutralize the lagging wires, and then the power factor may reach to the unity, nearly unity. ఈ కెపాసిటివ్ నెట్వర్క్ అనేది లీడింగ్ పవర్ ఫ్యాక్టర్ కలిగి ఉంటే ఆ లీడింగ్ పవర్ ఫ్యాక్టర్ అనేది ఆల్రెడీ ఉన్న ఇండక్టివ్ నేచర్ కలిగి ఉన్న లాగింగ్ పవర్ ఫ్యాక్టర్ని న్యూట్రలైజ్ చేసి పవర్ ఫ్యాక్టర్ని ఈక్వల్ యూనిటీకి దగ్గరగా తీసుకొస్తుంది, రైట్? సో what are the causes of low power factor is nothing but, so mainly utilized motors all are induction motors. That's why they may be operated with low lagging power factor. Second one, the transformer may be operated at lagging power factor because magnetizing current, where the magnetizing current appears, so it is a primary winding. So because of magnetizing current, so many losses occurred in the that may develop. That means primary winding may develop more currents, more leakage currents. So that leakage current may damage the winding, right? So because of low power factor, induction motor valla low power factor vastundi, transformer valla low power factor vastundi, induction generator valla low power factor vastundi, high intensity discharge lamps valla kuda low power factor vastundi. That means because of all these equipments, the power factor may be comes to low. So to improve that power factor, we have to utilize some equipments or some devices that may are connected to the across the equipment. ఏ ఎక్విప్మెంట్కి అయితే లో పవర్ ఫ్యాక్టర్ ఉందో, ఏ ఎక్విప్మెంట్ అయితే లో పవర్ ఫ్యాక్టర్తో రన్ అవుతుందో ఆ ఎక్విప్మెంట్కి ప్యారలల్గా మనం ఒక కెపాసిటర్ని కనెక్ట్ చేయడం వల్ల ఈ కెపాసిటర్ యొక్క లీడింగ్ పవర్ ఫ్యాక్టర్, లీడింగ్ వేర్స్ మే క్యాన్సిల్ ద లాగింగ్ వేర్స్ or may neutralize the lagging wires, that may improve the power factor of that equipment may be nearly equal to unity. Such in that manner the power factor may be improved. So causes of low power factor is nothing but because of all AC motors or induction motors, all the transformers may having low power factor, that because of it may develop high magnetizing currents, induction generators, highly intensity discharge lamps, right? These are all the causes. So now e causes valla, that is nothing but because of these causes what are the disadvantages appears. So first look at the figure, the power equation for single phase VL IL cos phi, for three phase root 3 VL IL cos pi, right? Therefore IL is equal to P by root 3 cos pi. So that means IL is inversely proportional to cos pi. Line current to load current is inversely proportional to the power factor, right? Now first one, I mean high I square losses, that is large copper losses. I square losses, that is equal to, if the power factor of the system is very poor, then the load current, పవర్ ఫ్యాక్టర్ తక్కువగా ఉందంటే లోడ్ కరెంట్ ఎక్కువగా ఉంటుంది. ఎప్పుడైతే లోడ్ కరెంట్ ఎక్కువగా ఉందో కాపర్ లాస్ ఎక్కువ అయిపోతుంది. సో దెన్ ది లోడ్ కరెంట్ డ్రాన్ ఫ్రమ్ ది సప్లై ఈజ్ వెరీ హై, ఇన్ విచ్ ద కాపర్ లాసెస్ ఆర్, దట్ ఈస్ I square R losses are more. As a result, efficiency may reduces. సో కాపర్ లాస్ అనేవి హైగా ఉండడం వల్ల ఎఫిషియన్సీ తగ్గిపోతుంది. అదేవిధంగా so it may not suitable for this time. Next, voltage regulation, poor voltage regulation. In alternators or transmission lines or transformers, large current at low voltage power factor causes very high voltage drops. ఎక్కువ కరెంట్ ఉండడం వల్ల IR drop, voltage drop is high. So whenever voltage drop is high, so the regulation may reduces. Greater conductor size. So load current is inversely proportional to the power factor. Hence, system having low power factor, then the transmitting fixed amount of power at a constant voltage. The current conductors have carrying large amount of current, then it required large cross sectional area. ఎప్పుడైతే కండక్టర్ సైజ్ ఎక్కువగా ఉందో దాని యొక్క క్రాస్ సెక్షన్ ఏరియా కూడా ఎక్కువగా అవుతుంది. ఎప్పుడైతే క్రాస్ సెక్షన్ ఏరియా ఎక్కువైందో దానికి ఉపయోగించే కండక్టింగ్ మెటీరియల్ ఎక్కువైపోతుంది. దట్ మీన్స్ కాస్ట్ మే ఇంక్రీజెస్, రైట్? నెక్స్ట్, what are the methods to improve the power factor, right? So static capacitor, synchronous condenser, phase advances, right? I am telling clearly only one point. So where the power factor is very low at that time, so we may connect a capacitor across that equipment. That device having a leading power factor that may neutralize the lagging power factor such that that equipment power factor may be nearly equal to 1, right? Here also, but static capacitor is very simple and the design is also simple, right? Easy installation. Losses will be low in the static capacitor. There is no moving parts, right? So it can work on normal conditions. They are in lightweight, so it can be easily transported or it can be easily installed. What are the disadvantages? Lifetime of the capacitor is only 8 to 10 years. With the changing load on or off the capacitor bank, which causes switching surges on the system. Whenever rated voltage increases, then it may cause damage the capacitor. So this is the power triangle, that is active power, reactive power 1, reactive power 1, reactive power 2, apparent power 1, apparent power 2. That means, so to find out the BC value, that is kVAR minus kVR2, that is kilowatt into tan phi 1 minus tan phi 2. Now another method is synchronous condenser. It is not a capacitor. The synchronous motor operates at no load condition Over-excited condition, then it is called synchronous condenser. ఒక సింక్రోనస్ మోటార్ అనేది ఓవర్ ఎగ్జైటేషన్లో నో లోడ్లో వర్క్ చేస్తుంటే అది కెపాసిటీగా యాక్ట్ చేస్తుంది. ఎప్పుడైతే కెపాసిటీగా యాక్ట్ చేస్తుందో వీ కెన్ కాల్డ్ యాజ్ ఎ సింక్రోనస్ కండెన్సర్, రైట్. That means whenever synchronous motor is over excited, then it provides leading current and works as a capacitor. When a capacitor synchronous condenser is connected across the supply voltage, then it draws leading current and partially eliminates the reactive component, then the power factor may be improved. And this is the advantage, long life compared to this static capacitor. Synchronous condenser having long life, that is almost 25 years, whereas in static capacitor 8 to 12 years, right. High reliability, no generation of harmonics, faults can be removed easily, requires low maintenance, but it is expensive. Why? Because maintenance cost is high, because we are utilizing motors, synchronous motors. Now phase advancers. Phase advancer is nothing but it is also one method of one of the faculty. Phase advancer is a simple one and it may be conducted on to otherwise to improve the power factor for induction motors. Induction motor యొక్క పవర్ ఫ్యాక్టర్ ఇంప్రూవ్ చేయడానికి మనం ఫేజ్ అడ్వాన్సర్ ఎక్కువగా యూటిలైజ్ చేస్తాం. At the stator windings of induction motor takes lagging current 90 degrees out of phase with the voltage. Therefore, power factor of induction motor is very low. The exciting ampere turns is nothing but MMF, are excited by external AC source. Then there would be no effect exciting current on the stator winding. Therefore, the power factor of induction motor may be improved. General ga static capacitor synchronous condenser lo ఒక కెపాసిటర్ని లోడ్కి ఎక్విప్మెంట్కి అక్రాస్ కనెక్ట్ చేయడం వల్ల ఈ కెపాసిటర్ యొక్క లీడింగ్ వేర్స్ ఆర్ లీడింగ్ పవర్ ఫ్యాక్టర్ మే న్యూట్రలైజ్ ఆర్ మే టెర్మినేట్ ది lagging current of the equipment, and the power factor of the total equipment must be nearly equal to unity. That is the concept. But coming to the phase advancers, so here there is no leading or lagging, just increase the ampere turns. If the exciting ampere turns are excited by the external AC source, then there would be no effect on the exciting current. Therefore, the power factor of induction motor may be improved, right. Up to this we discussed yesterday class also. ఈ కొంచెం మళ్ళీ నేను రిపీట్ చేయడానికి 23 minutes పట్టింది. సరే, నెక్స్ట్ most economical power factor when kilowatt demand is constant. Derivation. And before going to the derivation, a 2 marks question. What is the importance of power factor improvement? They are asking. Just for consumers, for generating stations. Importance in the power factor improve avadam valla. A consumer has to pay electricity charges for his maximum demand in kVA plus the units consumed. The consumer improves the power factor, then there is a reduction in maximum kVA demand. ఎప్పుడైతే పవర్ ఫ్యాక్టర్ని ఇంప్రూవ్ చేసామో కేవీఏ డిమాండ్ని మనం reduction of in maximum kVA demand, and consequently there will be a annual saving due to maximum demand charges. Although power factor improvement involves extra annual expenditure on account of power factor correction equipment, It may be important of power factor to proper values results in the net annual saving. That means for consumer itself, we may whenever we improve the power factor, so consumption of electric power reduces such that cost per electrical power, cost per unit is also reduces. Simply say that. So coming for generating stations, generating station is as much concerned with the power factor improvement as the consumer. The generators in power station are rated in kVA, but useful output depends upon the kilowatt. The station output kilowatt is equal to kVA. Kilowatt is equal to kVA cos phi, because cos phi is equal to kilowatt by kVA, active power by apparent power. That's why kilowatt is equal to kVA into cos phi. Therefore, greater the power factor of the generating station, higher is the kilowatt hour delivered system. That may leads improve the power factor, increases the earning capacity of the power station. That means generating station lo use cheyalante mana kilowatt manam penchali. Power factor perigite so kilowatt kuda perugutundi. Power factor tagite kilowatt tagutundi. That's why power factor is the basic factor. Now, what is the most economical power factor? Right? The value of power factor at which the net annual saving is maximum, is known as most economical power factor. The value to which power factor should be improved so as to have the maximum net annual saving is known as the most economical power factor. So you have to derive the most economical power factor. So again here two cases, when kilowatt demand is constant, when kVA demand is constant. When kilowatt demand is constant, when kVA demand is constant. Derive the most economical power factor when kVA demand is constant, when kVA demand is constant or kilowatt demand is constant, right? First of all, we have to derive the condition for most economical power factor when kilowatt demand is constant. Let us consider a consumer taking load of P kilowatt. So this is OA P kilowatt at a power factor of cos phi 1. And charge rate of kVA of maximum per annum. The consumer improves the power factor to cos phi 1 to cos phi 2 by installing power factor correction equipment. Let the expenditure incurred on the power factor correction equipment by Y per kVAr per annum. From the power triangle, cos phi 1 is OAB, cos phi 2 is OAC. Now kVA maximum cos phi 1 is equal to kVA maximum at cos phi 1 equal to kVA 1 is equal to, so what is the power factor? Cos phi is equal to kilowatt by kVA. What is kVA? kVA 1 is equal to P by cos phi 1. kVA 2 is equal to P by cos phi 2. Now annual saving in maximum charges is rupees kVA minus kVA 2. kVA 1 P into 1 by cos phi, that is secant pi 1 minus P secant pi 1 pi 2. Therefore x into P common, we have to take the P common factor, secant 1 minus secant 2. Right? So P into secant, generally from the power factor, definition, cos pi is equal to kilowatt by kVA. What about kVA? kVA is equal to kilowatt. kilowatt is equal to kVA into cos pi, right? So from this kVA1, kVA2, kVA1 kilowatt by cos pi, right? So that is kilowatt is nothing but P. Cos pi 1 is nothing but secant pi 1 minus P secant pi 2. Therefore, P into secant pi 1 minus secant pi 2. So reactive power at cos pi 1, that is kVAR1 is equal to P tan pi 1, kVAR2 is equal to P tan pi 2. Therefore, total kV leading kVAR taken by the motor, taken by the power factor correction equipment is P into tan pi 1 minus tan pi 2. This is the kVAR taken by the power factor correction equipment. For annual calculation, Py into tan pi 1 minus tan pi 2. Now net saving is equal to, so xp into secant pi 1 minus secant pi 2 minus yp into tan pi 1 minus tan pi 2. So in the above expression, only pi 2 is variable, remaining all quantities are fixed. Therefore, the net annual saving will be maximum. So when to find out the maximum value, minimum value means you have to differentiate the above equation with respect to pi 2. So ds by d pi 2 equal to 0, that is. So from that I am getting a condition sin pi 2 is equal to y by x. So therefore cos pi 2 square root of 1 minus cos sin square theta. Cos theta is equal to square root of 1 minus sin square theta. So that is cos pi 2 is equal to square root of 1 minus sin square pi 2. That is 1 minus y by x whole square. Right? This is the most economical power factor when kilowatt demand is constant. Next one, when kVA demand is constant. Right? Most economical power factor when kVA demand is constant. The kVA output is constant and is equal to the operand power S, that is operand power S. The power factor is improved from the cos pi 1 to cos pi 2 due to the addition of capacitance. Consequently, the real power is increased from P1 to P2. That the annual interest and the depreciation charges of capacitor is equal to y rupees y kVAR. That is the net return for kilowatt of installed capacity RSY is equal to so from the phasor diagram, leading kVAR supplied by the power factor improvement equipment is Q is equal to S into sin pi 1 minus sin pi 2. Now annual charges and capacitance is excess into sin pi 1 minus sin pi 2. Therefore, annual increase in revenue return because of increase in the real power, that is y into P1 minus P2. We know the P2 value S into cos pi 2 and P1 value S into cos pi 1. Therefore, ys into cos pi 2 minus cos pi 1. Net saving is nothing but ys into cos pi 2 minus cos pi 1 minus xs sin pi 1 minus sin pi 2. To find the, in this expression only pi 2 is variable, while all other quantities are fixed. Therefore, d by d pi 2 is of net saving. So then we have to determine the condition tan pi 2 is equal to x by y. Tan pi 2 is equal to x by, what is the cos pi 2? So cos pi is equal to cos of tan x by y. Right? So this is the power factor improving methods, and also most economical power factor derivation when kilowatt demand is constant, kVA demand is constant, right? So next class we'll discuss about the capacitors, where the capacitor is installed and వాట్ ఆర్ ది బెనిఫిట్స్ ఆఫ్ కెపాసిటర్ లొకేషన్, ఏ లొకేషన్లో మనం కెపాసిటర్ ప్లేస్ చేస్తే మనకు బెనిఫిట్ అవుతుంది. అదేవిధంగా ఆప్టిమల్ ప్రొసీజర్, ఆప్టిమల్ లొకేషన్ ఆఫ్ కెపాసిటర్, అదర్వైజ్ ఏ ప్రాక్టికల్ ప్రొసీజర్ ఫర్ బెస్ట్ లొకేషన్ ఆఫ్ కెపాసిటర్. All these things will be discussed, right?